Problem 11 says, what is the acceleration of an object that has a velocity of 25 meters per second and is moving in a circular radius of 10 meters? So they tell us that the velocity is 25 meters per second and our radius is 10 meters, and the acceleration is what we're looking for. We know that acceleration equals v squared over r, and we have v and we have r. So all we have to do is plug in our numbers. So we have 25 meters per second squared divided by 10 meters. And when we calculate that, we get an acceleration of 62.5 meters per second squared. Moving on to number 13, a 61 kilogram object is experiencing a net force of 25 newtons while traveling in a circular radius of 35 meters. What is its velocity? Here we know that its mass is 61 kilograms. We know that the net force is 25 newtons. We know that the radius is 35 meters, and what we're looking for is its velocity. Now we know that net force equals ma, and that is equal to mv squared over r. So we can cancel out this middle and have the net force equal to mv squared over r. And we need to solve for our velocity. So first we can multiply both sides by r, and it will cancel out from the right. So we'll have our net force multiplied by r equals mv squared. We will then need to divide by m on both sides, and then we can also square root both sides and get rid of the square. So what we'll end up with is velocity equals the square root of the net force times the radius divided by the mass. We have all of those numbers, so we can plug in 25 newtons times our 35 meters divided by our 61 kilograms. And when we do all of that math, not forgetting to square root your answer, you will get a velocity of 3.8 meters per second. Moving on to number 15, an object is experiencing a centripetal acceleration of 36 meters per second squared. While traveling in a circle of a radius 15 meters, what is its velocity? So again, they give us some information. They tell us that the acceleration is 36 meters per second squared. They tell us that our radius is 15 meters, and we are looking to find our velocity. So we are going to again use acceleration equals velocity squared divided by the radius as our equation. However, we're looking for velocity this time, so we do need to manipulate it. So we can first multiply r on both sides, and then we will get a times r equals v squared, and we will have to square root both sides. So we will end up with v equals the square root of a times r. If we plug in our values, we have our acceleration of 36 meters per second squared multiplied by our radius of 15 meters. And then after we square root that value, we'll get a velocity of 23.3 meters per second.